Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Hafizi bin Ahmad Lazim. My matric number is AN190168. My supervisor is Dr. Adam bin Kasan. So, this is my video presentation for PSM1. The title of my research is the effect of changing fuel flow rate of the flameless combustor to the hot air generator performance FHAG. So, we go to the introduction. First point of introduction is research background. So for background is hot air generator are piece of equipment that can heat any kind of building that need a fast and efficiency heating system. In oil palm factory, hot air generator are basically used to heat shrinking, drying and polymerize oil palm residue. The main source to run hot air generator come from a burner that produce heated energy by using conventional combustion. Using conventional combustion give a many bad effect, for example pollution emission. And basically the problem of the combustion is pollution. So to counter this problem, flameless combustion introduced to replace conventional combustion because it primarily benefit that can be burnt almost no carbon monoxide and nitrogen oxide emission. So currently right now, JTKM are strive to promote innovative combustion technology by adopting flameless combustion in Perak semi-industrial plant in order to keep up with today's technical breakthrough and generate environmental friendly combustion. So for problem statement is many industries still use conventional combustion for hot air generator. So the results show significant pollution emission for carbon monoxide and nitrogen oxide to environment. So the fuel flow rate of the flameless combustion on the hot air generator performance has never been studied before. So for this experiment, actually, JTKM tried to their first attempt to introduce the flameless combustion technology to industry. So for my topic, which means the effect of changing fuel rate to combustor flameless combustion to the hot air generator is my variable, which means I want to see if I change the fuel flow rate at certain point, what happened to the flameless combustor and the hot air generator. So next is the objective. So first objective is to determine the optimal preheating period to achieve flameless mode to the hot air generator. And second, to determine the effect of fuel flow rate of the flameless combustion on the hot air generator performance. Scope of the study is first, the experiment was carried out during the preheating stage to analyze the demand in optimal operation condition. A simple cylindrical form was developed, manufactured, and tested. For preheating stage, a NGV gas fuel was used and heated until the reach above auto ignition temperature and slowly changed into the flameless mode. So for my part, more focusing on preheating stage, which means the process of the flame turn into the flameless until it reach the auto ignition temperature. So from that process, I will collect data to observe the optimal operating condition to become flameless. Next is a significant of study. First is of course the pollution issue rising can be countered. So the low level of NOx and CO2 in atmosphere releasing are very low. And then in the future, this technology might be used to construct a gas turbine, coal power plant, and boiler that are less detrimental to environment if it is successfully applied. And then the use of flameless combustion may assist to prolong the life of the equipment by ensuring that there is no flame present in the combustion chamber. The next part is literature review. So first point for literature review is flameless combustion. Flameless combustion. For flameless combustion, I will talk about the characteristic of flameless combustion. First is flameless combustion is a burning fuel without presence of flame, and then well-distributed response zone, which this is mean at the combustion chamber, all the combustion chamber part is the reaction zone, which means the combustion reaction is complete. There is no excessive product, and then the temperature peak less than 1300 degrees Celsius. And temperature in combustor chamber does not significantly different. And then next is recirculate exhaust gas present at the high temperature, thus decrease the formation of CO and NOx. So next part is benefit flameless combustion. First is NOx and CO reduction. So basically these two emissions are related to each other, which means if the temperature can be decreased, so the production of nitrogen oxide and carbon monoxide can be decreased. And then flameless combustion uh, provide a great temperature, which means the temperature cannot above at certain set points. For example, 1030. If we compare to conventional combustion, it can reach around 1080 until 2000 degrees Celsius. So that temperature will be triggered to produce this pollution. And then next is energy saving. So when we talk about energy saving, it's related to thermal efficiency. So to minimize the thermal efficiency, we control the input, which means we control the fuel. So less fuel, thermal efficiency will be decreased. For energy saving will be greater. And then next for low equipment maintenance. For low equipment maintenance, there is two factors that be related. First, if we compare to room temperature, when increase air combustion temperature, decrease the ignition delay time dramatically. So this is provide a good maintenance and equipment in terms of cost and in terms of cost. So for next is conventional combustion. So the features of conventional combustion is burning fuel with the presence of the flame. So for the example that I can give is a candle. So reaction zone only occur at the surface between flame and oxygen. This is because when we see the fire, the reaction zone only occur at the thin surface between fuel and oxygen. That's why the reaction combustion for conventional is not complete. And then the temperature peak almost 1800 into 2000 degrees Celsius, thus lead the formation of carbon monoxide and nitrogen oxide. And then temperature in combustor high at the flame part only. So this is the graph comparison temperature between conventional and flameless combustion. At the above is conventional, at the bottom is the flameless. So as we can see the graph for the conventional, at the flame part the temperature is very high, and then after that the temperature drop. So it shows us at the combustor chamber there is certain part will receive the high temperature, in other part the temperature will not same at all, which means there is significant differently range between auto ignition temperature before and after. As we can see for the flameless, the temperature before auto ignition and after auto ignition, the temperature quite constantly same, which means there is no significant reading different uh, between auto ignition temperature before and after. So this is good for maintenance combustion chamber, which means the lifetime for combustion chamber will be long compared to conventional combustion. So for this graph is the graph of optimal carbon monoxide and nitrogen oxide emission level. So carbon monoxide is the black one, and then the nitrogen oxide is the green one. So as we can see from this graph provide a proof that emission for flameless combustion nearly zero, which is good for environment and eco-friendly user. What is methodology? So the first point of methodology is a flowchart. So for flowchart, this is my flowchart. So at the first, we do a research article and problem statement, and then we design and development flameless combustor. At this phase, we need to design our own flameless combustor. Once we are already designed, we will go to the next phase, which is prototype fabrication, and then we go to the prototype testing. If prototype testing, we found that we are fail to test the prototype, we need to go back to design and development. But once when the testing is successful, we proceed to the experiment setup and data analysis, and then we do conclusion. So this is expected outcome from our experiment. First thing first, there are no visible flame, and next is the level of the noise is very low, and then next is soot generation is minimal. The terms soot generation is the smoke produced for combustion, for normal combustion, which is a conventional combustion. The smoke produced very high, so the smoke release include CO2, CO, and NOx. So for flameless combustion, what can we expect is soot generation is minimal. So next is nitrogen oxide and carbon monoxide emission from fuel burning are very low. And then last but not least, the hot generator performance in good condition. So for hot and generator performance, we can identify the performance is good or not by taking the temperature before and after it's operating. Before it's operating and after it's operating, and then we compare the temperature. So that's all for me. Thank you.